Good morning, good afternoon, good evening, everyone, and thank you so much for joining us. Today I have with me Nav Mathur, who is our Senior Director for Global Solutions here at Neo4j. He has over 20 years of experience in IT solutions and has been with Neo for almost 3 years now. So welcome, Nav. Thanks so much.
Thanks, Greta.
Today we're talking about a really interesting topic that I think we've seen come up quite a bit more recently. And so I wanted to sit down with Nav and kind of dive deep into knowledge graphs, specifically at financial institutions, because it's something that we really have seen a lot of people coming to us to ask about. A lot of financial institutions have started to reach out to us about it. So Nav, I think let's just level set first, kind of just dive into what exactly is a knowledge graph and how is it different than I think a knowledge base and that kind of thing.
Yeah, like you said, I think a lot of people are talking about knowledge graphs. There's a lot of conferences going on around this topic. So yeah, I think first things first, how do you differentiate the knowledge graph from what we traditionally all have been used to, the term knowledge base? And so typically when you put any data, any knowledge into a flat structure like a traditional database, you essentially, when you search for that same data, you get back exactly what you put in, right? Versus when you add a piece of data or knowledge into a graph, this data now gets connected to other pieces of data, contextually related. And so when you search for the same data, you now get back additional pieces of information with it. So more context, more knowledge, and the more data you put into a graph and that is connected together, the value of this entire data set that you have exponentially increases.
Yeah.
And so you get a lot of data that you didn't even think was related when you started thinking about putting this knowledge graph together.
That's really interesting. Yeah. So what then makes a good knowledge graph? What are some components of?
Yeah. So what I've done is I've kind of come up with these 4 pillars or key principles, however you want to look at it, of what a knowledge graph really is, because I think there's a lot of misconception around what exactly is a knowledge graph. Is it the same thing as MDM? Is it the same thing as a data warehouse or a data lake, right? But I think one of the first things obviously is having the data be contextually related and being put in the form of a connected data structure like a graph, right? So that's obviously the key idea. But behind that is automation, right? So you don't want to be manually curating this data every time you get new data to put into this graph. You want that to be automated. Now that automation can happen through kind of a traditional data ingestion pipeline that is constantly looking at the data coming in and putting it into the graph. Or you can have more machine learning techniques to do that, like natural language processing, and use that to essentially tag the data and then get the features out of the data and then put it into the graph and connect it together that way. The third pillar really is explainability, and by that I mean when you put data into a graph, you are able to go back and ask questions of that data and traverse through this data set to different points in the graph to then answer that question. So you can go back and explain how exactly this question was answered, what were the key facts that you traversed to that helped you answer that question. Unlike a more machine learning or deep learning techniques where there's some kind of black magic happening in the algorithm that is providing the prediction or the response to your question. But unlike that, in a graph, you can always explain how you got to that, right? And lastly, obviously having a lot of different kinds of data in your graph, right? So both structured, unstructured data from different silos in your organization, bringing it together. I think these, to me, are the 4 pillars of what a knowledge graph should be.
Yeah, interesting. And so when I typically think of knowledge graph, I kind of think of it as it relates to search sort of as kind of like the foundation for a good kind of search platform. But I think with those 4 pillars, you're kind of hinting at some really interesting use cases that you could build on from that. So how are FinServ companies using knowledge graphs? What are they building some cool things with that?
Yeah, I'm really glad you caught on to that because the first thing that comes to mind is obviously using a search function to search for the right content. Maybe if it's a people or person graph, then you're looking at how are these 2 people connected together? Maybe they're at the same address or they have the same phone number or something like that. Or if I'm traversing from a person A to a person B through other people, what is the relationship amongst those people, or something like that. And those would be like typical search functions and very basic functionality from a knowledge graph. But then to make it real use of this knowledge graph and to really get the power of prediction or inference that you're capable of now, or impact analysis is another really good use case from this. So typically what I recommend is putting some sort of a recommendation framework on top of this knowledge graph to really extract those things out. So for example, we have Itaú Unibanco, in the financial services space, that is using us in a similar fashion to do credit risk analysis, to look at the creditworthiness, not of just that individual applicant, but also just looking at that applicant in the context of other applicants in that space, right? So really using the power of graph to look at adjacent data, adjacent companies, what can maybe, if they have a relationship with a poorly performing company, that can kind of lower their inherent creditworthiness, things like that. And so those kind of impact analysis use case get enabled through something like this.
That's really interesting. So I think I kind of want to dive into one of those use cases in particular. You mentioned a recommendation framework. I know we've got a kind of a recommendation solution here at Neo. Wondering if we could dive into a demo of that and see a little bit more of how we can get started.
Yeah, sure. I'd love to do a demo, but before that, let me just kind of set that up a little bit.
Sure.
So what we have developed is a financial services recommendation framework, and what that does is this is an example where we've put together a demonstration of portfolio news recommendations. So if you look at the lives of analysts, financial analysts, they are tracking a bunch of companies. They're inundated. Even all of us are inundated with news. But imagine for them, looking at the right news is money, and so they are super interested to understand or get recommendations on exactly the news stories they should read up on that impacts them on their daily life, impacts the trades that they do, the analysis of the companies that they have to churn out on a day-to-day basis. So this portfolio news recommendation service essentially trawls through the daily news on a real-time basis and puts together a dashboard of the news stories that they absolutely need to follow depending on the companies that are in their portfolio and also what topics of interest that they have. And we'll look at that demonstration here shortly. So let's go right into it.
Great.
Okay, so let's look at the dashboard for the portfolio news recommendations application. Let's log in with the analyst that's following tech companies. His name is Harlan. And right as we log into the application, the system automatically calculates all the recommended articles for this person and also the organizations that they need to take a look at that's top of mind, that should be top of mind for them this day. And this is based on the companies, the tech companies that Harlan follows and the news articles related to those companies. But also news articles related to other companies that are related to those companies. And in addition to that, the topics of interest to Harlan. So Harlan can set the topic weights of the different topics of interest right here and submit that. And so you can get the recommendations on both articles and organizations right here. You can also look at the article here and read through it if you like. And you can also get an explanation of the score of the article, which I'll show you in a moment. But you can also see how the article relates to different organizations that have shown up in the recommended organizations list. So for Ping, for example, is related to Microsoft. If you look at this article on lawmakers hitting the like button after Facebook CEO visits Capitol Hill, you see that it's not only just related to Facebook, but also to Amazon, Apple, and Alphabet. And so if we want to get an explanation of why this score is the top here, we can look at this in more detail and see a graph widget that explains how all of this is related to the article. So we have the news story here, and it's related to acquisitions and mergers and acquisitions, which is of interest to Harlan. It's also related to legal issues, and company investigation is a subtopic there. So behind the scenes, we are getting this data, this news data from Refinitiv. And we also have a graph of the companies and their relationships to one another. And I'll show you that in the data model in just a second. But here, let's also look at it from the organization's perspective. And so if you look at Airbnb, we see that there is an article about that in the Financial Times. Or if you look at Amazon, there are multiple articles about Amazon here that shows up in the recommended list as well. And so if we click on the explainability of the recommended organization, again, we get a pretty detailed graph of all the different articles and the topics. And this is your analyst, Harlan. And it's a little messy here, but we can obviously make a much cleaner application. This is just for demonstration purposes, but you get the idea. It can show you basically all the different articles that are related to Amazon, and obviously Amazon has a lot of stories popping up every day, given that it's a highly capitalized new economy company. And so you get the pretty complex graph here. But I think that's the real power of graphs, and being able to give you that explainability in real time. So all of this application is actually running on top of Neo4j's recommendation framework. The recommendation framework uses a grand stack based architecture. So if you want to learn more about the architecture of this application and the different components used, you can look at grandstack.io and get a more detailed view of that. All right, so let's show you a little bit behind the scenes on this. Actually, before we do that, let me just change this, the topic weights, and show you how the recommendations can change. So let's say now the analyst is more interested in legal issues, not so much on M&A, very interested in labor issues, not so much on financials and capital changes, and very much interested in disasters and accidents. If you submit that, it refreshes, and it looks at a new set of articles, or a refreshed set of articles based on the different topic weights now. Okay, so let's go and look at the data model next. So here's the data model. So it's very, very simple. So you have the user or the analyst. You have topic groups, and there are weights attached to the topic groups the analyst provides. And then there are lots of subtopics or topics that are grouped together in topic groups. And then there is an article that is connected to the topic. And the article is also connected to the organization. The organization has many relationships, self-relationships. So an organization can be affiliated to another organization. An organization can be a supplier of another organization. An organization can have an ultimate parent. This is based on the ownership. And the organization can have an immediate parent that is different from the ultimate parent. And the organization can have deals with another organization. This is all the data that we're getting from Refinitiv, and we have put it in a graph. And then on top of that, we're getting the news stories as well from Refinitiv. This here is basically a single relationship between article and organization that we have split up for performance purposes. And so that's why it's showing multiple different relationships based on each day of the news stories. That just helps us to accelerate performance of the overall system. Here's more detail on that, in case that was not clear earlier. But it's a really simple data model, and this is the basis of the knowledge graph underneath, on which our recommendation framework that is providing the recommendations to the application. The way this system is architected is that as soon as the article comes in, we send it to a tagger, a natural language tagger, that uses the article information, the contents of the article, to then tag the news story to the appropriate organizations and to the topics, which in turn are related to topic groups, and the user follows organizations and weighs the topic groups of interest. So this is how this is put together. All right, so now you have a good idea of the data model. Let's look at the recommendation engine now. So this is Neo4j's intelligent recommendation framework, and it's divided into two concepts: engines, which produce recommendations, and database connections, which represent the underlying Neo4j database. So in this case, it's the portfolio recommendations database that I was just showing you the data model for. And here it is using these two engines, the article engine and the organizational engine. So let's go into this framework and look at the article engine. So the article engine, what it's doing is it's matching for all articles in the last 7 days related to the organizations that Harland is following. And then it does a discovery. So there are some specific phases that we have encoded into our recommendation framework. And that helps essentially so that you don't have to write any infrastructure code. You just write your business logic within these phases, and it's like a pipeline of steps. And you produce the output or the output recommendations. To learn more about the recommendation engines, you can look at Neo4j/solutions, neo4j.com/solutions, and go to the recommendations area. Or we also have recently published a new blog series around this topic. So you'll get a lot of information there about our recommendation technologies. But here, what it's doing is it's essentially discovering a set of articles given the analysts, the companies that they're following, and the topics of interest to them. And we are scoring these articles based on the count of the tracked organizations that they relate to. And then we're also further scoring that by adding the weight assigned to the article to the topic groups that by the user. So this is the cipher for that. And then what we're doing is we have a boost phase that is boosting the articles that are based on the weight assigned to this topic by the user. So we're adding an additional boost so that those articles that are very closely related to the topics of interest are boosted higher up in the order. There are a couple of additional phases for this pipeline. There's an exclude phase to remove some noise from what you've discovered. Perhaps you don't want to include in the final output. There's also a diversity phase to not have clumps of very similar recommendations, so you can have diverse set of recommendations. And again, you can learn more when you go online. Okay, next let's look at the organizational engine right here. The organizational engine essentially discovers all the articles associated with each individual organization, and it optimizes for and puts up at a higher score level the organizations that have the most articles that are related to the topic groups that the user has weighted highly. So this is the cipher for that. And as we saw that certain organizations had a higher count of articles, but it also kind of removes some of the noise associated with that. So if an organization on an average like Amazon or the FANG stocks, if they have a lot of articles every day, it'll remove that noise, and also so that lesser companies or smaller companies that have articles, one or two articles that appear occasionally, are also bubbled to the top, and not just the highly stocks that have a high degree of news stories on them every day. All right, now that we've looked at the recommendation framework in detail, let's switch our focus to the visualization aspects. So this is Bloom. Bloom is Neo4j's visualization product. And so let's look at the data in a visual form. So let's look at the analyst Harlan, who we are following. So this is Harlan. So this is a natural language based search interface. So you can just type keywords, and it's going to look up those in the database and pull that up into the visual layer. So here we have Harlan, and let's look at the organizations that Harlan follows. So I just type organization, and I get the relationship of Harlan and all the technology stocks that Harlan's following. So here we have those. And then let's look at the topic groups that Harlan has weighted. So those are the topic groups. And then if I just click on Harlan and inspect that node, we can look at all the relationship types, and we can see the different weights on the different topic groups here. So for example, legal issues is weighted at 5 versus capital changes is weighted at 2, which is what we saw in the UI layer earlier on. All right. Now that we have seen that, let's look at all the topics related to these topic groups. So if we click on that, we get many more topics, and we can see the relationship of these topics, the topics group. So
let's look at, for example, legal issues. You can see that conviction right here, trial, these are all related to legal issues and many others. All right, so now let's explore the organizations again. And since we're looking at organizations and relationship of other organizations to that organization, so we're looking at least 2 hops deeper. Let's look at all the other organizations that are related to the first level organization, the 20-odd tech stocks that Harlan follows. And we can see that's a huge number of organizations. We have about now, about 1744 nodes that are on display here. And then if we look at the different articles that the application has to traverse through to calculate the recommendations, we're looking at organizations and the articles attached to that. So you can see these are all the articles that are attached to organizations. But then we're not only looking at these articles, we're looking 2 hops deeper at the organization level. So look at another hop out to second tier organization and the articles associated with those. So you can see this is what, in this instance for Harlan, it's traversing through all of these nodes in real time across these relationships to calculate out what to recommend in terms of the articles and organizations for Harlan as an analyst to see, so that he uses his time appropriately in looking at the articles that are most relevant and the organizations that are most relevant for the news stories in the last 7 days. So that's the demo, folks, and hope you enjoyed that.
All right, so we have a couple of questions. All right, so how do we get access to the recommendation framework that you were demoing?
Yeah, so the recommendation framework that we have today is being built with customer input. And so the way we have it available right now is through our consulting services organization. We offer it for free, so there's no upfront fee for the framework itself. But you need to use our consulting services in order to help you to customize the framework. So, because everybody needs a slightly different front end, perhaps, or adjustments to the framework to suit their needs. So we feel that that's the most appropriate way to make that available through our consulting services.
And how does that? Should they email or?
Yeah, you can email solutions@neo4j.com or sales@neo4j.com, and we can set you up. We do proof of concepts all the time with our customers as well. And we offer trial licenses to both our enterprise edition, which is what the recommendation framework works only on our enterprise edition, and we offer trial licenses to both the framework as well as the Neo4j database enterprise edition.
All right, great. And then a question about the NLP tool that you were using in the demo.
Yeah, that is actually OpenCalais. It's a service by Refinitiv, which is offshoot of Thomson Reuters. They spun that out as a separate company, so that's the data company now of the erstwhile Thomson Reuters, which got acquired by BlackRock. But Refinitiv provides that. But we also have other partners. If you have other types of NLP needs that are not really satisfied by OpenCalais, then we have other partnerships that provide NLP services, and we can connect you with some of our partners in that space as well.
All right, this one's a really interesting one. So it's talking about data warehouses, data lakes. Is that something that you're seeing kind of being turned into knowledge graphs? How do you get started? How do you see them being used in this context?
That's a great question, because
Really
I think that's exactly what most people are faced with, because they already have a lot of this data in some form or fashion,
Right.
and usually it's been dumped into a data lake or in an old technology like a data warehouse. And they need to unlock that into a graph to really start making use of it in this fashion. So yeah, we have lots of different architectures that take data from a data lake or data warehouse, pump it into the graph. Again, as I said before, through some kind of a ETL pipeline or an NLP-based interface. But you have to keep in mind two very important things. One, to have the right data model in Neo4j for this data, and it's not exactly similar to the data model you would have like in your data warehouse or your data lake for that matter. You need to really tackle this data model from the types of questions that you're going to ask of this data, and construct the data model from that perspective, and that's hugely important. The other really important piece is to bring only the relevant metadata. So you don't need to bring your entire transaction, all the details associated with your transaction that you store in your data lake, for example, but you only bring in the relevant metadata that can contextually connect your data together, right, from all your silos or different entities that you have in your data lake. And that's the metadata that you bring into Neo4j. So that kind of compartmentalizes the data or makes it more discrete, and that helps to then write more performant queries and get the responses in real time that you're looking for.
Yeah, so it's really unlocking the value of the data that's within your data warehouse, your big data lake, that kind of thing.
That's exactly right.
Pulling that into Neo.
Yeah, and Neo is really acting more as the grease to your existing investments in your data warehouse and your data lake, right?
That's a really great point. Yeah, great question. Okay, and then so where are you seeing these projects initiating within this organization? Because I think as we kind of were talking about, like there are a lot of different ways that knowledge graphs can be built and a lot of different use cases, and so.
Yeah, I mean, we see a lot of spots, right, where these things start from. One of the areas that is fairly common is innovation groups, because they are chartered to use new technology to benefit financial services organizations. They are leading adopters of new technology typically. So there are innovation groups in different organizational units, and those are typically that reach out to us. There's also the core technology areas of the bank that organically some developers may have found Neo4j, played around with it, piloted some use cases, and now they see some value there. That's when they contact us to improve that or to help them really sell that internally within an organization, to the business folks. And those are typically how these projects get started mostly.
Cool. And so I think we have time for one more question, and I usually like to wrap it up with, how do we get more resources? How do we find out more about this topic? Where should we go as a next step?
Yeah, obviously, as I said before, you can reach out to us over email, Neo4j, info@neo4j.com or sales@neo4j.com, or reach out to me directly at solutions@neo4j.com, and be happy to respond to you and get you connected to the right folks to provide you more input on what you're doing and how to take your particular initiative forward with Neo4j.
Great. Thanks so much, Nav, and thank you all for joining us today. This recording will be made available to you after we wrap it up and after the editing is all done. And thank you for joining us. Thanks, Nav.
Thanks, Greta.